Hi everyone, welcome back. If there is one theorem or one formula that you all must know, especially if you are preparing for examinations like IIT JEE, it has to be the Leibniz Theorem or Leibniz Integral Rule. Leibniz Theorem is one of the most important, most useful theorem in calculus, and the theorem allows us to calculate the derivative of integrals of the form that you can see on the screen. Integral of g of t dt, where the limits are variables of functions of another variable x. The limits are ax to bx. If I denote this function by f of x, then Leibniz theorem tells me that we can calculate f dash of x, the derivative of fx, without really evaluating the integral. That is the whole idea. We don't have to evaluate the integral. Let's see the formula first. So if I denote this integral by f of x, then f dash of x is given by the Leibniz formula. The formula is super easy to remember. What we have to do is, uh, if we have the integrand g of t, then g of upper limit multiplied by the derivative of upper limit minus g of lower limit multiplied by the derivative of lower limit. This is the formula, very easy to remember. Now let's try to understand the formula and theorem using a couple of examples. First example, we have a function fx which is expressed in terms of an integral, and we need to find out the differential of this function, the derivative of this function. As you can see, we cannot really evaluate the integral as such. E raised to the power t square dt is something that we cannot evaluate using our standard techniques. But good thing is we don't really have to evaluate the integral. We can use Leibniz theorem, f dash of x equals to, and you can observe that in this case g of t is nothing but e raised to the power t square. So what we get here is f dash of x equals to g of upper limit, that is 3x, multiplied by the derivative of 3x minus g of upper limit multiplied by the derivative of lower limit. Sorry, this was upper limit. G of 3x is going to be e raised to the power 3x whole squared, that is 9x square, multiplied by derivative of 3x, which is 3, minus g of x, that is e raised to the power x square, and its derivative is 1. So we have derivative of f, that is f dash x, equals to thrice of e raised to the power 9x square minus e raised to the power x square. If you want to simplify it, it's not necessary, but we can simplify it by taking out e raised to the power x square as the common factor, but the result is not really that simplified. So this is what we are getting, derivative of function of x. Very simple to calculate using the Leibniz theorem. Now let's try solving one more example, one more problem. And in the second problem, we have to evaluate the limit of a function which is expressed again as integral. So before we start solving, let's first investigate the integral. In the integral, we have we have integral of sine t square dt over x raised to the power 6. The limits are 0 to x square. We can observe that the integral is with respect to the variable t, so we can pull out x raised to the power 6 outside the integral without affecting the result. So this is what we are getting, integral of sine t square dt divided by x raised to the power 6, and we have limit x approaching to 0. In the next step, we need to investigate the limit. So if we investigate the limit, we can very easily see, as x approaches to 0, in the numerator we have an integral which will also approach to 0. As x approaches to 0, the integral in the numerator will also approach to 0, because both the limits of the integral are coming out to be 0. Similarly, as x approaches to 0, the term in the denominator, which is x raised to the power 6, this will also approach to 0. So in this particular example, we have a limit of the form 0 by 0, 0 by 0 limit. And to evaluate these type of limits 0 by 0 form, when we have a term containing integral, we can use a very special theorem. It's called Lopitals Theorem or Lopitals Rule. Lopitals Rule. And the Lopitals Rule goes like this, that if we have to evaluate a limit of the form fx over gx, where both fx and gx approaches to 0 as x approaches to 0, then this limit is equivalent to evaluating the limit of x approaching to 0 f dash x over g dash x. In simple words, we can take derivative of numerator and denominator separately. So in our case, we can do the same process. Limit x approaches to 0, we can take the derivative of numerator and we can take the derivative of denominator separately and then evaluate the limit. The derivative of numerator is something that can be calculated using the Leibniz theorem that we just saw. So we will get sine of upper limit, that is x square square, which is x raised to the power 4, multiplied by the derivative of upper limit. Derivative of x square is 2x, minus, if we repeat the process with the lower limit, which is a constant number 0, we will get 0, divided by derivative of x raised to the power 6, which is 6 times x raised to the power 5. And we'll simplify it a little bit. We'll cancel out couple of terms and we are getting sine of x raised to the power 4 divided by thrice of x raised to the power 4. Sine of x raised to the power 4 divided by x raised to the power 4. This limit is going to be 1 as x approaches to 0. So our answer is coming out to be 1 over 3. The limit of the original integral is coming out to be 1 over 3. So this was one really useful application of the Leibniz theorem. And again, Leibniz theorem is quite a useful concept in calculus. And I hope all of you got the hang of it using these two examples. Please don't forget to like the video, subscribe the channel and share the video with your friends. Thank you very much for watching. Have a really nice time.